Okay, the second question on this sheet says that you're on the roof of the school, 46 meters above the ground. That's a really high school. Our library is like 10 meters. And your physics teacher, who is 1.8 meters tall, is walking alongside the building at a speed of 1.2 meters per second. You wish to drop an egg on your teacher's head. Where should the teacher be when you release the egg? Assume the egg is in free fall. Okay, so there's two parts to the question. One is the egg falling, and the other is the teacher walking in. I thought I had it set up if I could find a piece of paper. So much for saving time. There it is. Okay, so the egg's falling, the teacher's walking in. You drop it, so VI for the egg is 0. And A for the egg is 9.81 meters per second squared. And the delta D is 46 meters. The delta D and the A are both down, so you don't have to worry about negatives. Everything's going down. For the teacher, it says the teacher is walking at a constant speed, unbeknownst to the fact that there's an egg going to fall on their head. Okay, and you're looking for the delta D of the teacher. How are the times connected? Well, the time that it takes the egg to fall is the time that it takes the teacher to walk in. And actually, the teacher was what? 1.8 meters tall. So the delta D of the building isn't really, that the egg has to fall, isn't really 46 meters. The delta D that the egg has to fall is really 44.2 meters because you want it to hit the teacher on the head. You should always read the whole question before you start it. Okay, so how are the times connected? They should be the same. All right, so we don't know the delta T of the egg. We also don't know the delta T of the teacher. Where should we start? Well, we should start with the egg because we only have one unknown. Once we get that, we can use it for the teacher because then we will only have one unknown for it. So we have a VI and a delta D, and we want a delta T. So first with the egg, we would do delta D is equal to VI delta T 1/2 A delta T squared. And this goes to 0, and we're solving for time. So to multiply both sides by 2, divide by A. So T squared is equal to 2 times our 44.2 meters, taking off the height of the teacher, divide by 9.81 meters per second squared. And then you're going to take the square root. So 88.4 divided by 9.81, it's going to be just over 80. Take the square root, 9. Oh no, I didn't take the square root. Before you take the square root, 9.0112 seconds squared. Take the square root, 3.002 seconds. That's the time it takes the egg to fall. So now, where should the teacher be? Well, we know VAV is equal to delta D over delta T. So delta D of the teacher is just VAV times that delta T. So delta T D of the teacher is 1.2 meters per second times the 3.002 seconds. So the teacher should be 3.60, maybe 2, depending on where you round it, meters back. Okay, so that's number 2. Number 3. Number 3 says, visitors at an amusement park watch divers step off a platform 21.3 meters above a pool of water. According to the announcer, the divers enter the water at a speed of 90 kilometers per hour, ignoring air resistance. Is the announcer correct? So here you're wanting to find the VF, which with they hit the water, to see if it's really 90 kilometers per hour. Okay? So it's actually only a one part. They step off, so VI is 0. They fall with gravity, 9.81 meters per second squared. It says the platform is 21.3 meters above the ground. Down and down, and you're solving for VF. What equation do you know that has a VI, a VF, an A, and a delta D in it? hopefully you're saying VF squared equals VI squared plus 2A delta D. VI goes to 0. VF squared equals 2 times, everything's going down here, so you can call down positive. 2 times 9.81 meters per second squared times 21.3 meters. That's going to be VF squared. Don't forget to take the square root. And when you do, you get 20.44 meters per second. And if you switch that to kilometers per hour, it's 73.59 kilometers per hour. So the announcer was lying. He is not going, they are not going 90 kilometers per hour. There's a B part to the question which says, what initial upward speed must the diver leap with to enter the water at 90 kilometers per hour? So now in part B, we're saying, okay, so they're going to jump upward, and A is going to still be 9.81 meters per second squared down, and we want the VF to be 90 kilometers per hour down, which is 25 meters per second. And the delta D, the change in height, is still going to be 21.3 meters, right? You can jump, if you're starting here, you can jump up in the air and then fall back down, but your delta D is still 21.3 meters, and that's going to be down. Okay, so you're looking for VI, same equation. VF squared is equal to VI squared plus 2A delta D. Rearrange, VI squared is equal to VF squared plus 2A, oops, that's a minus 2A delta D. VF has to go in as a negative, so negative 25 meters per second, and it gets squared, minus 2 times negative 9.81 meters per second squared, because he ends up below, negative 21.3 meters, because they end up below. Do the math, take the square root, and get 14.39 meters per second up. Now, oops, take the square root, I said. That's already square rooted. Now, if you switch that to kilometers per hour, it's 51.8 kilometers per hour. And I tell you, if you have someone who can jump off a diving board at a rate of 51.8 kilometers per hour, sign them up for every sports team you have, because they have very strong leg muscles and you want them on your side. All right, number 4. So number 4 says, a football is kicked vertically upward from the ground, and a student gazing out the window sees it move upward past her at 5 meters per second. The window is 12 meters above the ground. How high does the football go above the ground? So your two sections here, it's like separated by the window. So below the window and above window. And it's moving this way. So it has a VI down here that we don't know, I believe. Student gazing out the window sees it move, and so the VF of below the window is 5 meters per second up, and the VI of above the window is 5 meters per second up. A, of course, is 9.81 meters per second squared down, and it is and above the window too, 9.81 meters per second squared down. And it's the window is 12 meters above the ground, so delta D down here is 12 meters up. And it says, how high does the football go above the ground? So it's going to go up until it stops, until the VF is 0. Okay? And we don't know the height above the window that it goes. All right, so the first step before you can answer part A is you have to find VI. So for below window, you would do, and you have VF squared, and you have VF VIA, so do VF squared is equal to VI squared plus 2A delta D. So VI squared will equal VF squared minus 2A delta D. So VI squared is equal to 5 meters per second squared, so 25 minus 2 times negative